Hi, and welcome to the sixth section of this course, Paint Application. We use the Canvas widget to define a custom widget in Section 5, Building an Audio Player. The Canvas widget is truly one of TK-Enter's highlights. It is an incredibly powerful and flexible widget. Let's therefore devote most of this chapter to looking at the Canvas widget in detail. We will now develop a paint application. The application will let the user draw freehand lines, straight lines, circles, rectangles, arcs, and other polygons. It will also let the user define new complex shapes. In addition to exploring the Canvas widget, we will also develop a tiny GUI framework on top of the TK-Enter interface. As you will see, frameworks are a great way to maximize code reuse. This makes them a powerful tool for rapid application development, RAD. These are the key objectives of this section. Master the Canvas widget API. Learn to build and use custom GUI frameworks for maximum code reuse and rapid application development. Learn to use the Color Chooser module of TK-Enter. Learn to use the TTK Combo Box widget. Get to know about the available widget methods, reinforcing things that we have learned in previous projects. Now, we will see the first video of Section 6, Creating a Tiny Framework. The goal of the video is to build framework. In its final form, our paint application would look like this. There are no external library requirements for this section, so let's dive into the code. So why do we need another framework on top of TK-Enter? If we need to build just a single program, we need not build a framework. However, if we find ourselves writing the same boilerplate code over and over again, a framework is what we need. That is, a framework is a tool that lets us easily generate generic and often used patterns with ease. Consider, for example, the menu used in programs. It is such a common element in most programs, yet we need to handcraft each menu item every time we sit down to write a program. What if we could further abstract to simplify menu generation? This is where frameworks come in handy. Say you have a program that has 10 different top-level menus. Say each of the top-level menus has 5 menu items. We will have to then write 50 lines of code simply to display these 50 menu items. You have to link each of them manually to other commands, besides having to set tons of options for each of them. If we keep doing this for all of our widgets, our GUI programming becomes an exercise in typing. Every extra line of code that you write adds to the program complexity, making it more difficult for someone else to read, maintain, modify, and/or debug the code. This is where using a custom framework comes to our aid. Let's develop a tiny framework that makes menu generation easy for us. We create a file, framework.py, and create a new class, framework, to the file. Every class that uses this framework must inherit from this class and should not pass the root window as an argument to this class by calling the super method like. This will make all methods defined in the framework class available to the inheriting class. We will now define a method, build_menu, which takes a tuple in an expected format as input and automatically creates the menu for us. Let's define an arbitrary rule that each group of menu items must be represented by a single entry in a tuple. Further, we come up with a rule that each item in the tuple must be presented in this format. For instance, passing this tuple as an argument to the build_menu method, which is highlighted here. The code will generate 3 menus like this. The first item of the string before dash represents the top-level menu button. Each subsequent part of the string separated by a / represents one menu item, its accelerator key, and the attached command callback. The position of the ampersand symbol represents the position of the shortcut key to be underlined. If we encounter the string sep, we add a menu separator. Now that we've defined the rules, the code for build_menu is highlighted here. The method, build_menu, operates on a tuple by the name menu_definition, which must specify all desired menu and menu items in the exact format, as previously discussed. It iterates through each item in the tuple, splitting the item based on the dash delimiter, building the top menu button for each item left to the dash delimiter. It then splits the second part of the string based on the comma delimiter. It then iterates through this second part, creating menu items for each of the parts, adding the accelerator key, command callback, and underline key using another method, _add_menu_command. The _add_menu command iterates through the string and adds a separator if it finds the string sep. If not, it searches for an ampersand in the string. If it finds one, it calculates its index position and assigns it to the underlying variable. It then replaces the ampersand value with an empty string because we do not want to display the ampersand in our menu item. If an ampersand is not found in a string, the code assigns none to the underlying variable. Finally, the code adds a command callback accelerator key and underlying value to the menu item. Note that our framework adds only the accelerator key label. It is the developer's responsibility to bind events to the bound keys. Our demonstration of making GUI frameworks ends here. We can now use this method to define literally hundreds of menus simply by adding one new line for each group of menus. However, this is rather rudimentary framework. The rules for defining items are completely arbitrary. The choice of delimiters means that we can no longer use the character dash, slash, and ampersand that we've used as delimiters in any menus that we define using this framework. Our framework does not lay rules for any other widgets. In fact, this definition is not even sufficient to generate other types of menus like the cascading menu, check button menu, or radio button menu. We will, however, not extend the framework further, as it is sufficient to hit home the concept behind framework design and usage, and that is all we need to use in our Paint application. We've also included a small test in the framework.py file. If you execute the file as a standalone program, it should pop up a window and define some menus for testing. Using a framework for smaller programs may be overkill, but they are invaluable assets for large programs. Hopefully, you should now be able to appreciate the benefits of using frameworks for larger programs. Now that we have the code for the build_menu, we can extend it to add as many menu items as required without having to write repetitive and similar code for each of them. Nice! We've successfully created the Tiny framework. In the next one, we'll use this Tiny framework in defining the menu for our drawing program in the next step.